All right, question number 18 for practice assessment 1 for unit 3 says a 55-gram sample of ice at negative 17 degrees Celsius melted and increased to a temperature of 22 degrees Celsius. How much energy was absorbed in this change? Well, even from some of the language, we can tell that we are dealing with a heating curve because we've got energy that's being added, being absorbed, it's melted. Lots of indications tell us that's going to be a heating curve. So let's go ahead and draw in our heating curve here. And now let's go ahead and highlight our segments. Now we start out down here at negative 17 degrees Celsius. And then it's going to end up at 22 degrees Celsius. So for that to happen, we first need to warm up our ice. Then we need to melt our ice to liquid water, and then we need to warm up our liquid water. So we've got 3 different segments that we need to calculate. And each one of these needs to be done separately. We've got 1, 2, and 3. So let's go ahead and start by warming up our ice. Our ice starts out at negative 17 degrees Celsius. So segment number 1, we're going to warm up our ice at negative 17 degrees Celsius. The question is, how much energy is absorbed? So we're going to use Q equals M times C times delta T, where our mass is, in this case, 55 grams. Our heat capacity is that of ice, which is 2.1 joules per gram times degrees Celsius. And by the way, we get that by looking at our constants. We've got the heat capacity of solid water, 2.1 joules per gram degrees Celsius. And then our temperature change is from negative 17 up to 0. So it changes by 17 degrees. When we do the math, we end up with 1,963 0.5 joules. 1,963.5 joules. Now, next, let's go do that next segment, which is the melting phase. Here we're going to melt the ice, turn it from solid water to liquid water. So we're going to use mass times the heat of fusion. Again, our mass is 55 grams. Put that over 1. We're going to multiply that by the heat of fusion, which we find, again, on our constant charts. We see it's 334 joules per 1 gram. And doing the math calculation, we get 18,370 joules. Now, finally, we've got liquid water that we need to heat up to 22 degrees Celsius. So we're going to take Q equals M times C times delta T, where M is our mass, 55 grams. Our heat capacity of liquid water is 4.18 joules per gram times degrees Celsius. And we're going to take it from 0 degrees Celsius up to 22 degrees Celsius. So we have a 22 degrees Celsius increase. And when we do the calculations, we then end up with 5,057.8 joules. Now, adding all of these up, we'll get 25,391.3 joules. And that's the total amount of energy needed to heat up this sample to 22 degrees Celsius.